Alright, here, so let's cover the 7172 quiz. The first section here is asking us, based upon the equation of an exponential growth and decay function, is it growth or decay? Now, the key component that we have to look at is not the a value. We don't care what the a value is when determining growth or decay, but instead the b value. If you're larger than 1, you are growth. If you are less than 1, now what you have to think about is what is 3/5 as a value, right? And 3/5 is definitely less than 1. It's a 0.6, if you're to think of it as a decimal. That's decay, and that would actually be a 40% decay because you're only keeping 60% of the value. Now this one here is there because people think, oh, well, fractions, that's got to be decay. Not necessarily, because 11 over 2 is really 5.5, which is definitely greater than 1. So this one would also be growth. So don't just see fraction and assume decay, because you have to determine what the b value is. All right, so here we have a population of brown bears increasing at a rate of 14%. So we do need to know that it's increasing. That's important. Write an equation to model the number of bears in X years. So our starting value A is given to us. Now to determine this b value that we'll raise up to X years, it's going to be 1 plus the rate as a decimal. So we have 1.14. All right, now when we need to calculate using our equation the number of bears in 10 years, we are simply going to type that in on our calculator, except we're going to make the exponent a 10. And when we do this, we've got a population of bears now landing in at, or around, this is approximately 4,448 bears. So this one's talking about purchasing a vehicle. So a new van is purchased for $50,000 and it loses 25% of its value each year. Write an equation to find the value of the van in X years. So once again, we have the initial starting value here at 50,000. For the b value, though, it's not going to be 0.25 because that's how much it's losing. So you have to do 1 minus the decay rate as a decimal. So our b value on this one is 75%. Because if it's losing 25% of its value, we're keeping 75%. And then once again, when we go to evaluate this, we plug it in on the calculators and we raise it up to the 5th power for year 5 and get the value of the van to be $11,865, approximately. So here we're asked to graph y equals 3 to the x. And the important part of this one is we're going to need to scale our graph so that all the points fit. Now, there's 2 ways of doing this. One is you could go into your calculator and you could enter into y1, 3 to the x, and look at the table, go to second graph, which takes you to the table, and match up the values. Another way is, though, just to understand that all that's happening here is we are filling in the exponent with the given x value. Now, negative exponents like the -2 tell us to simply take the reciprocal. So that would be 3 to the 2nd power, but in the denominator. So that's a 1 over 9. Now 3 to the -1 power is 1 over 3. 3 to the 0 power, anything to the 0 power is 1. 3 to the 1st power is 3. 3 squared is 9. 3 cubed is 27. So we'll need to scale the graph. I'm going to count it by 9s, just because. So here we've got 9. Here we've got 18. Here we've got 27. Now, when we're going to graph these, especially the negative ones, like that -2 1/9, that's barely off the x-axis. 1/3, also barely off the x-axis. Now, when we're looking at 0, it's at 1, which would be 1/9. So still not very tall yet. When it was 1, we were at 3, so about 1/3 of the way. At 2, we were at 9, and then at 3, we were at 27. So you can really see the exponential growth functioning happening here to where we are coming in from this asymptote here, and then we start to grow, slowly, and then all of a sudden it takes off very fast. Now, the next value that would be on there, 3 to the 4th power, would be 81. So this guy has to travel all the way up to 81 by the time we're at the x of 4. And so it'd be very, very steep on that. So the question 6 asks, will this graph ever touch or cross the x-axis? Nope. If we extended this table down to be -3, -4, the values just keep getting closer and closer to 0, but never quite reach it. And that's that concept of an asymptote. 7 saying, hey, what would happen to the graph we just made if we changed the equation to y equals 3 to the x plus 5? Well, this plus 5 is a k value. That means we would take our graph, so our graph would make a vertical shift, and it's going to go up 5. So that would move the asymptote up 5. It would take this entire graph there, or if you want to think of it, you'd be adding 5 onto all of those different y values is another way you could think of it as well. All right. So here we have some interest. Alex has $2,400 invested in a savings account. The account pays 4% annual interest. How much money will be in the account after 8 years? And this is just regular interest here, so it's not compounding. So we're going to use this formula here. So we have y is equal to, A is always that initial amount. So we have 2,400 is our principal amount. And then we have a 1 plus. Now, 4% as interest is 0.04, so not 0.4, 0.04. And as we raise that up to an exponent of 8, that's what we'll be typing in to figure out how much money is earned after 8 years. If we type that in on the calculator, we'll see that we have now earned, total, the amount of $3,284.57 as we round there. Now, this one is going to be using the formula we are looking at most recently, the PERT formula, to where the interest is compounding continuously, to where we're not just gaining interest on the initial amount like we did on the previous one, but where we gain interest, and then that new total becomes our new initial starting point. So it's compounding interest because you're essentially earning interest on top of your interest. All right, now both of these work in a similar fashion. P is your initial amount, and then we have E as, so we're multiplying the button on our calculator. It's a constant that we'll learn more about. And then we have the rate as a decimal, which will be 0.05, and then time is 4 years. Now what's important on this formula is that you do not add 1 onto that. The 1's exclusive to the regular interest formula. This one's just the rate. So when we plug that in, using E as the button on our calculator, which is second division sign, and then up in the exponent we have 0.05 multiplying by a 4. This account is now up to $366.42. We can apply the same concept. All right, multiplied by E to the rate as a decimal, which will be 0.065 to 20. Now this one's going to be much larger because that time period of 20 is a lot longer than the 4 years we previously saw. So this one we'll see when we multiply it out. 650 has grown quite a lot into $2,385.04. We'll work more with the PERT formula moving forward. The important thing to remember, though, is to just use the rate as the actual decimal. Do not add the 1 to it. If you do that, your numbers will be comically large. They'll be super big, and you'll probably get an error overflow message on your calculator. Here for this one, a music store sold 200 guitars in 2007. They sold 180 guitars in 2008, so you can definitely see a decrease there. The number of guitars that the store sells is decreasing exponentially. If this trend continues, how many guitars will the store sell in 2012? So we're doing some business estimations here. We're going to round to the nearest guitar if necessary. So this formula here is essentially the exponential version of the rate of change formula that you might be familiar with from Algebra 1, y2 minus y1 over x2 minus x1. So let's go ahead and give this a try. We find this by plugging in our different values. Year is our x, so our y2 will be the different amounts. So we sold 180 in year 2. We subtract by how much we sold in year 1. Divide that amount by year 1. And when we do that, we get this right here, which tells us we are losing 10% of our sales each year. So this is what we'd want to take away from 1. So 1 taking away that 10% would give us a B value here of 0.9. So they're only keeping 90% of their business as years move on. And then for our equation, the A value is always that initial number, which was 200. Right? So the reason this equation works, that's the initial amount, and each year we're only selling 90% of what we sold in the previous year. And they wanted us to estimate how many will we sell in 2012. Well, 2012 is, if we take that and subtract it from the initial 2007, 5 years later. So what we need to calculate is this. Initial amount, 90%, so we have a 10% decay, raised up to 5 years. And when we do that, it looks like they're going to be projected to sell 118 guitars in year 2012.